So we have properties of logarithms. So technically a logarithm is what?
It's another way of writing exponents.
Thank you. It's technically an exponent. Why that's important for what we're doing today is because it behaves like an exponent, and the rules, so we have product, quotient, power to power, they function the same way as a regular exponent. Alright? So essentially, if you have log base b of n times n, you can expand that or you can condense it. Okay? So this is technically equal to log base b of m plus log base b of n. That's expanding it. And I can also use that to condense. Alright, so this, just condensing it, the addition, if I have adding two logarithms together, I should automatically think multiplication. It's the product property, because when I multiply like bases, for instance, if I had x to the 4th times x to the 5th, if I wanted to combine those, what would I do with the 4 and the 5? You would add them. So this would become x to the next. Same idea. Okay? Addition implies multiplication when you're talking about logarithms. How would I condense this then into one single logarithm? So I would have log, the base is going to stay the same. So log base 2 of what? What do I do with the 7 and the 4? You multiply them. So it would be 28. Okay. So again, just to recap, if there isn't a base written, what is it? Correct. It's 10. So then this would become log. What do I do with the 25 and the 4? Will this simplify? That's 10. This would be it'd be log base 10 of 100, which is 10 squared. We would reduce it down to 2. But we're just condensing. Okay, so what about 3? So again, it's going to be a single logarithm, log base 4. And then what do I do with the 2x and the 4x squared? What will it become? Well, 8x to the 3rd power, because you would add the exponents on the x. Multiplication, right? So, on the second one, we're expanding, which means we're trying to make it a little bit longer, using multiplication in this instance. This one's kind of a little bit weird, but if I wanted to expand log of 6, I need to think of, okay, well, what are two numbers that multiply against 6? Yeah. So, do you agree that this is equivalent to log of 3 times 2? Yeah. I'm just changing the way 6 looks. And then how do I expand that using the property of log? It'd be log 3 plus log 2. Yep. And there's a reason we do this, okay, and why we're learning it. Because we get to solve these equations sometimes. Alright, so again, 45. Two numbers that multiply to give me 45?
9
and 5. So this would essentially be 9 times 5. So then when I expand it, what would it look like? Yep. Now what if I did log of 5? Log base 7 of 5 first, does it matter?
No.
No, it doesn't matter.
Because it equals the same thing, right?
Well, because a multiplication and addition are commutative, so it doesn't matter order. Quotient is a big fancy word that means what? Division. Essentially, we're dividing. Now, if we go back to our laws of exponents, when I divide like bases, what do I do with my exponents? You subtract them. So in this property, when we're talking about division, subtraction and division go together. Okay? So this would essentially be log base b of m minus log base b of n, just in general. Does it matter order in this case? Does order matter when we're talking about division and or subtraction? Yes, absolutely does. So your top number is, or your first number is always going to be on top, okay? And the second number will always be on the bottom. If I look here, and I condense that into a single logarithm, what would it condense to be? So it'd be log base 3, and it's 24.
Right?
Can I reduce this? Yeah,
Yes.
and you should. So this would be log base 3 of 3, which technically is 1. Here's some. That's a 1. Doesn't really look like a 1, but it's supposed to be 1. Okay, how about the second one? So log base 2, and this would be 15, not 0, because it's 15 divided by 15, which is 1. So log base 2, 1, which if you did evaluate, that would end up being 0. They're not always going to end up working out to something like that, but if you can reduce it, you should. Have 4, this is kind of weird, but you have log base 8 of 4. So what is a number when I divide will be 4? Sure, yep. So now there's more than one answer to this, right? Because 16 and 4 would also give me 4. But if I just say, okay, I want this to be 8 divided by 2. So I would have log base 8 of 8 minus log base 8 of 2. So top number always goes first, bottom number always goes second. Now this one's already a fraction, so I don't have to think, it's already 1 over 3. So how would I extend this? Log base 5 of 1. What's my top number? Minus.
Log base 5.
Yep. Just expanding. Okay, so now this one is power to a power. Okay, so just if I were to do x to the 4th to the 7th power, what would I do? What would that simplify to be? Just this right here. Yep. When you take a power and you're raising it to another power, you multiply those two numbers together. Alright, so what this technically does in a logarithm is if you have an exponent in your logarithm, so you have log base b of n to the n, what that does is that brings the n down here in front. So this would be n times log base b of n. Flip that around. That would mean if there's already a number in front of the logarithm, it brings it back up into the exponent. All this does is it moves it from exponent down in front, or from down in front back into the exponent. It's just moving that exponent in number. So right now, we're condensing, even though it doesn't make it that much smaller. I have this 5 out here in front. Where does it need to go?
At the end.
Right. So that would go up there. So you'd have log base 4 of 2 to the 5th power. Now, should I deal with 2 to the 5th power, or should I just leave it alone?
You can put the
You can. So you could do log base 4 of 32. Alright, so 14, how would I condense that? Again, that number out front will go back into the exponent. So log base 2 x to the 7. We're expanding. All that means is we're taking an exponent and moving it down in front. That's how you expand.
So just backwards.
Yep, just backwards. So the 7 will come out in front. 7 times log base 2 of 8. Yep. Now technically, what is log base 2 of 8? 3. So this would actually become 7 times 3, which is 21. Yeah, so we're kind of doing all of our properties in one. So if I'm looking at this, what am I gonna do first?
So would you put the 2 right behind the 6? Or
Right
square
there,
it?
right? So then I have log of 6 squared minus log 9. Is there anything else I can do with this? What is 6 squared?
36.
Right. So then this would be log 36 minus log 9. How do I condense those? You're going to do division, right? And 36 divided by 9 is 4. So this would end up being, so I'll write it out. So it would be 36 divided by 9. So that is log of 4. Can I do anything else with log of 4? No, because the base is 10. Okay, so, alright. So again, 7's going to go back up. So when I move this 3, do not take the negative with it. The 3 is separate from that. What do I do with the 3 and the 2 that's already up there?
What?
Well, I'm going to move the 3 back up. But what do I do with the 3 and the 2 that's already up there?
Times it.
Right, because if I were to move the 2 back down, move it in front, I'd multiply them. So same thing, if I move it back up, I'm going to multiply it. So log base 4 of u to the 7 minus log base 4 v to the 6. Alright, so condensing log base 4, and what's that going to look like?
From the C, U to 7, and then B to 6. Oh, over?
Yeah. Expanding, okay, just working backwards. What do I do? So I have how many things in my parentheses? 3. So I have to break it up. It's going to be into 3 logs. Okay. What operation's going on? So you have log base 6 of x.
Oh,
Because I want to break it up. So times, so the addition.
plus log base 6 of y plus log base 6 of z.
What do I do with the 4?
Oh, no. Plus log base 4.
No, it's still log base 6.
Oh,
So I'll write it out. So log base 6 of z to the 4th. I'm almost done. Okay, but if there is an exponent up here, it needs to come down into the front in order to be expanded all the way. Log base 6 of x plus log base 6 of y plus 4 times log base 6 of z. So that's... And then what am I going to do with the 9? Yeah. And you can do that in one step. That's fine. I don't have a problem with that. And then it would be minus log base 4. So that's what I would do as well. I would say, well, I'm going to square those first and just get rid of that. So log base 7, that'd be q to the 8th, r to the 4th. Now I don't have the exponent deal in there. So when I do the expansion, it'd be 8 times log base 7 of q plus 4 log base 7